Okay, so this is part two of the lecture that we were actually doing. We were trying to solve the past paper question. It was October, November 19, 0620 chemistry paper. This was the theory extended version of the paper. We were on this question. We were solving this question, and we were at part C. Now, the part C of the question states that a student used the following electrochemical cell. The reading on the voltmeter was 1.10 volts. Let me first explain how an electrochemical cell works. You have two metals, and I'm going to do the whole description. Zinc is more reactive. So you have a reactive metal and you have an unreactive metal. And the other side, you have copper electrode. Copper is less reactive. Now, one is reactive, the other one is a little less reactive. Now, the reactive metal has a higher tendency to lose electrons. So, zinc, all metals, they like to lose electrons, but the reactive ones, they kind of like to lose electrons even more. So, zinc is going to lose electrons very, very quickly. How did I figure out which one was reactive and which one was unreactive? Let's Google the reactivity series. That's going to come up in front of you. Remember to remember this reactivity series. You need to know this by heart. There's a numeric given over here as well. You have to remember this by heart. Zinc is somewhere over here, and you have copper, which is kind of at the bottom. So zinc is more reactive than copper. Anyways, so you have the reactivity series in front of you. You must remember that. Now, zinc has a higher tendency to lose electrons. It's going to lose a lot of electrons, and a bunch of electrons would accumulate over here because zinc would start losing electrons very, very quickly. It's going to lose electrons faster compared to copper. Copper is very unreactive. It's not going to lose electrons in the first place. So, a lot of zinc ions are going to be produced over here. Why? Because zinc likes to lose electrons. And where would all those electrons travel? Those electrons would start traveling to the other side because all the electrons, they're going to electrons repel other electrons. So they're going to repel each other. So all the electrons are going to get knocked out to the other side. So there's going to be a flow of current, and the voltmeter over here would register a voltage. So there would be current flowing. Now the electrons have to go somewhere because if they don't have a place to go, remember the copper electrode finishes over here. So the electrons travel, they reach copper, but they have to go somewhere. Now, in the solution, you have these H plus 1 ions. It's sulfuric acid. So, sulfuric acid has these H positive ions. And these H positive ions would be attracted to these electrons. So, these electrons that are coming in from the other side, so the electrons that are being lost over here, they travel to the other side. And over there, it's H plus 1 that ends up gaining those electrons. And your equation, since H is diatomic, it's going to be 2H plus 1, and they would be gaining 2 electrons to form hydrogen gas. And hydrogen gas is going to escape, taking away those electrons. So the electron flow would continue. Electrons are going to be produced at one end, they're going to flow to the other end, where ions in the solution would end up gaining those electrons. So there would be a constant flow of electrons produced over here, and they're being gained over there, and constantly removed over there because hydrogen gas would form bubbles. So you're going to see these bubbles forming at this end. So you're going to see bubbles forming because of hydrogen gas forming. Draw now the first question. We pretty much answered everything. Hopefully in this question, draw an arrow in the diagram to show the direction of electron flow. We've done that. Suggest the change, if any, in the voltmeter reading if the zinc electrode was replaced with an iron electrode. Now let's have a look at the reactivity series. Zinc is being replaced by iron. So where is zinc? Zinc is here. Iron is less reactive. So what's going to happen is iron is lower down in the reactivity series. So iron. So the question is suggest the change, if any, in the voltmeter reading. Iron is less reactive, and we need to explain our answer as well. So iron is less reactive. So has a lower tendency to lose electrons. So it has a lower tendency to lose electrons. So it's not going to be losing electrons very easily, which means the voltage would be lesser because less electrons would be flowing. If instead of zinc you have iron over here, iron doesn't really like to lose electrons. It's less reactive compared to zinc. So not a lot of electrons would accumulate over here, and not a lot of electrons are going to flow to the other side. So the current would be lesser. So lower voltage on the voltmeter. The next part is that the zinc electrode was replaced with a silver electrode. The reading on the voltmeter was minus 0.46 volts. So just by the sign of the voltmeter, the reading became less. So now let's do this. Ignore the working that we've already done. Let's do this in another color. Uh, just focus on the pink. Okay, the working on pink. Now this side there's copper. The other side he's saying it's silver. Now, copper is relatively more reactive compared to silver, so it becomes, remember it's all relative. It's relatively more reactive if there's silver on the other side. If there's silver on the other side, then copper compared to silver, both of them are unreactive. That's without a doubt. If you look at the reactivity series, silver is below copper in the reactivity series. So both of them are really down in the reactivity series. They both are reactive. So so silver is very unreactive. Going back, but copper is kind of very slightly more reactive compared to silver. So copper is going to have a slightly higher tendency to lose electrons. So it's going to start losing electrons, producing electrons over here, and those electrons would flow to the other side. I mean, this side is going to have slightly more electrons compared to the other side. So focus on the pink, ignore the red working that I did earlier. That was for the previous part. Now I have a copper electrode and I have a silver electrode on the other side. So the flow of electrons is going to be the opposite. Remember, electrons always flow. I'm going to write this down as well. Electrons always flow from more reactive to less reactive. So that's going to be the movement of electron flow. So that is the movement of electron flow. And so why are we getting a negative voltage? The reason we're getting a negative voltage is because the direction of flow of electrons is the opposite. So just by the sign of the voltmeter reading becomes negative. Direction of electron flow is reversed. From copper electrode to from copper, which is more reactive, relatively more reactive, to the silver electrode, which in our case is going to be the less reactive electrode now. Let's move to question number 5 now. This one is about organic chemistry, and the question states that methanol is. So the question states methanol is a member of the homologous series of alcohols. Methanol can be made from methane in a two-step process. Methane is reacted with chlorine to produce chloromethane. Chloromethane is reacted with sodium hydroxide to produce methanol and one other product. What conditions are needed for step one? So focus on step one. Step one, and let me briefly explain what's happening in step one. In step one, what's happening is you have methane. Let's write down the reaction. Alkanes don't have a lot of reactions. It's that's probably the one reaction that you have to study. That's methane reacting with chlorine. Now, ultraviolet light is needed. What happens is substitution happens. This chlorine over here goes and knocks out one of the hydrogens and takes its place. So instead of having four hydrogens, methane now has one chlorine. So this is chloromethane now. And the H that gets knocked out also reacts with chlorine to produce HCl. Now, UV light or sunlight is needed for this reaction because it helps to break this chlorine-chlorine bond. So, what are the conditions needed for step one? That's UV light. The next part is write the chemical equation for the reaction which occurs in step one. We can write this equation. You can either write the whole displayed structural formula, or you can it's CH4 reacting with chlorine and it's producing CH3Cl plus HCl. Remember, an HCl molecule is always produced. I think they did not mention in the question, but it's always produced. State the type of organic reaction occurring in step 1. This one is called substitution because one group is substituted by another. So this is known as substitution. Next is complete the chemical equation for step 2. Now, this reaction is not in your course. So whatever is given, you have to just figure out. It's just guesswork. You just have to figure this out on your own. This is not part of your course. So if you look over here, you just need to balance this. What's missing? You have a bunch of atoms over here. The bunch of atoms should appear on the right side as well. So what is not appearing? Na is not there, so there should be Na, and Cl is not on this side, so there should be. It's got to be Na. One Na and one Cl is missing, so it has to be NaCl. That's the product that would be on the other side. Next part is show a dot and cross diagram to show the electron arrangement in a molecule of methanol. Show outer electrons only. Now carbon shares 4 electrons. So each of the hydrogen shares 1 electron each. Oxygen shares 2 electrons. Now the symbol for oxygen should be different. So I'm going to use a filled circle over here. So this is all the sharing that's done. Now oxygen has 6 electrons. It only shares 2. Remember, group 6 needs 2 electrons. So group 6 atoms, they share 2 electrons. But out of 6 electrons, 2 are shared. That means 4 electrons are left, which are known as lone pairs. Hydrogen only had 1 electron, so nothing is left. Carbon had 4 electrons. It ended up sharing 4 electrons. So carbon also has nothing left. Anyways, we're done with the dot and cross diagram. Part C states methanol reacts with propanoic acid to form an ester with the molecular formula. You're supposed to name the ester. Name one other substance formed when methanol reacts with propanoic acid and draw the structure of an ester. Which is what I'm going to do is I'm going to do the first 2 parts first. So methanol, this is the space I'm using. It's not for part 3. This is for part 1 and part 2. So I have methanol, and methanol is supposed to react with what do I need to react it with? Propanoic acid. If it's so it's methanol reacting with propanoic acid. Propanoic acid is prop means 3 carbon atoms. So this is your prop. It's a propanoic acid. Carboxylic acid has this functional group. And this carbon would have 2 hydrogens, and this carbon makes 4 bonds. So this would have 3 hydrogens. So these two are going to react. Remember to draw the functional groups in front of each other because they're the ones that are going to react. The H would be lost and the OH is going to be lost over here. So when the H and the OH are lost, they end up forming a water molecule. So a water molecule is going to be formed. And this molecule over here is going to slide in and it's going to bond with the methanol molecule. And water is produced as a result. So a water molecule is given off. So name one other substance formed when methanol reacts with propanoic acid. That's the answer to that is water. And the answer to the previous one is we have to name the ester. So how do you name the ester? Esters are named in 2 parts around the ester link over here. This side has 3 carbon atoms, so this is prop. This side has 1 carbon atom. 1 carbon atom is meth. So that's how an ester is named. So one side is meth, the other side is prop. The single O side is called vial. The double bond O side or the carboxylic acid side is O8. So the name of the molecule is methyl propanoid. So we're going to write that down. So it's going to be methyl propanoid. Now moving to the next part 3 of the question, which states draw the structure of an ester, which is a structural isomer of the ester named in C1. We need we need to draw an isomer of this. So isomer it's still in ester. Remember, he's talking about drawing in ester. What I'm simply going to do is that let me mark the atoms that I'm going to change in blue. The ester link, this side had 3 carbon atoms and this side had 1 carbon atom. An isomer could be that around the ester link, let's say this is my ester link. So in total, I had 4 carbon atoms. And what I'm going to do is I'm going to have 2 carbon atoms on this side and 2 carbon atoms on the other side. And I'm going to add in the hydrogens. So this would have 3 hydrogens, this would have 2 hydrogens, and this would have 3 hydrogens. Anyways, this over here is, so this over here is, so this over here is your isomer. It has the same number of atoms. You can count the number of atoms, exactly the same number of atoms. This side has 2 carbon atoms. So I've just changed it a little bit. You just have to change the structure, and that is what I did. I did not increase or decrease the number of carbon atoms. Just change the arrangement of the atoms. And there are many ways. I could have added 3 carbon atoms over here and 1 carbon atom on the other side. It would have still been an isomer for. So this is answer to part 3. State the conditions needed to form an ester from a carboxylic acid and an alcohol. So the conditions that are needed are concentrated H2SO4, and you need reflux. Reflux is heating. Reflux is heating, but with a condenser on top, so that since an alcohol is a very alcohol and carboxylic acids are volatile substances, they're going to escape the container if you try to heat them. They're going to evaporate. So which is why you add reflux, which is you put a condenser on top. You don't allow anything to escape. So this pretty much ends this paper. We've done most of the paper in the previous part as well. But now we have completed the paper. As soon as I get more time, I'm going to try and solve even more questions related to past papers.